Section 2.5, Writing a Function Rule. Basically, it's called writing an equation. Let's start with the Solvent Problem. Here's our Solvent Problem. You don't need to write this down because it's always going to be online for you to view, but I do want you to show the work in the Solve It area in your book. You and a friend are swimming 20 laps at a pool. One lap is the distance across the pool and back. You both swim at the same rate. Your friend starts first. The trail of arrows shows how far he has already swum. What equation gives the distance you have swum as a relation or as a function of the number of laps your friend has swum? How far have you swum when your friend finishes? So let's look at our picture first. Here's your friend. Your friend has gone down and back. That's one lap. And then has gone 15 feet or 15 meters more. So how much farther is your friend right now than you? 25 down, 25 back, and then 15. Your friend is 65 ahead of you. So what you have to do is you have to write your distance, which we're going to say D, is equal to a function of how many laps your friend has swum. So we're going to use L. L represents the number of laps your friend has swum, not you, in order to figure out how many total meters you have gone. So what do we know? Well, we have 20 laps at a pool. That's how far we're going. But wait a minute, a lap. How far is a lap? A lap is down and back. So how many meters is one lap? It'd be 50. So we do 50L. Now, if we wanted to know how far you've gone, all we'd have to do is do D equals 50L. But we have to know it in the relationship to your friend. Your friend has already gone 65 more than you. So in order to find your length or your distance that you've swum, what are you going to have to do? When you plug in how many laps your friend has gone, you're going to have to subtract 65 from that because your friend is 65 more than you. So to figure out your distance, you have to subtract 65. So that would be your function. D equals 50L minus 65. Now, how far have you swum when your friend finishes? Well, when your friend finishes, how many laps will they have gone? Right here, 20. So plug 20 in. 50 times 20 is 1,000 minus 65 would equal a distance of 935 meters. And that would be the answer. Now let's look at the Got It problem on page 129. A landfill has 50,000 tons of waste in it. Each month, it accumulates an average of 420 more tons of waste. What is the function rule that represents the total amount of waste after M months? So, what do we know? We want to know, first of all, M after M months. So, M months is going to be the independent variable. And the landfill has 50,000 tons of waste in it. So, we want to know a function rule that represents the total amount of waste. So, we could do T for total, we could use W, it doesn't matter. So, M is going to be the independent. The amount of waste is going to be dependent depending on how many months has passed. So there's a few ways to do this. Let's start with W. W is the total amount of waste. How much waste do we start with? 50,000. That's the constant. That's not going to change. Every month, what's being added? 420 more tons. So you're adding to it 420 tons a month, and month is M. You could write this as 420M plus 50,000 or 50,000 plus 420M. That's it. That's all you do. So let's look at practice 1 underneath that. Practice 1. A worker's earnings E are a function of the number of hours worked N at a rate of $8.75 per hour. So what's the dependent and independent variable? The number of hours you work is your independent. The amount you make is dependent on how many hours you work. So let's use total earnings, which is E. So we'd have E equals what? You make $8.75 an hour. Hours is N, so you would make $8.75 N. That's it. So now I want you to flip the page and try number 2 on your own. Pause the video and see if you can do it. Number 2 states, the almond extract A remaining in an 8-ounce bottle decreases by 1/6 of an ounce each batch B of waffle cookies made. So how, actually that sounds really good, waffle cookies. Interesting, never heard of a waffle cookie. Alright, so the almond extract A remaining in an 8-ounce bottle. So what do we start with? Well, A is our total amount equals, well, we start with 8 ounces. What happens every time you bake a B batch of waffle cookies? You take out a 1/6. So minus 1/6 for every batch. And that would be your answer. A equals 8 minus 1/6 B. Now turn to page 130 and look at the Got It problem A. What we are going to do now is we are actually going to write a function rule and then evaluate. This is really not difficult. So let's start with A. A kennel charges $15 per day to board a dog. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost for n days of a boarding plus a bath. How much does a 10-day stay cost? So let's start what our total amount is. We want to write a function rule for the total cost for n days. So the number of days is going to be represented by m. The total cost we don't know, so let's just use T. It doesn't tell us a letter. So we start with the total cost. How much does it cost per day? $15. So we start with $15 per day. Number of days is M. Plus, what are we going to have? We have to have a flea bath. That's a one-time fee of $12. So our function is T equals 15M plus 12. Now we want to know, how much does a 10-day cost? How much does a 10-day stay cost? So the number of days is 10. All I do is plug in 10 for the number of days, which is N. 15 times 10 is 150. 150 plus 12 is 162. Please make sure you label. Your answer is $162 for a 10-day stay. Part B then says, does a 5-day stay cost half as much as a 10-day stay? Explain. Well, let's plug it in. 5 days plus 12. 15 times 5 gives us 75 plus the $12. That gives us $87. Is $87 half of 162? No, because making the stay shorter only takes half of the daily charge. We still have to pay $12. You're not paying half of $12. You're paying half of the $15 stay because you're only paying 5 days instead of 10. However, the $12 is still the same regardless of how many days you pay. I want you now to do number 3 under practice A yourself, and then I will tell you the answer. Number 3. A helicopter hovers 40 feet above the ground. The helicopter climbs at a rate of 21 feet per second. Write a rule that represents the helicopter's height h above the ground after t time. So you should have written this. H equals 40 plus 21t, or h equals 21 plus 40t. Now we want to know, after 45 seconds, what is the helicopter's height? So you plug it in, 40 plus 21 times 45 seconds, and you would get a height of 985 feet. And make sure you label. Now turn your page to page 131. Under the Got It section of problem 3. Now problem 3, this is another section This time you're going to be writing a nonlinear function, which means you're going to have an equation with exponents with your variables. So A, we're going to start with A. Write a function rule, which is an equation. Write an equation for the area of a triangle whose height is 4 inches more than twice the length of its base. What is the area of the triangle when the length of its base is 16 inches? So let's first, I'm going to draw a picture since we have a triangle. So it says the height, so your height would be, whoa, that's not right. Let's try that again. The height from top to bottom, it says is 4 more than twice the length of its base. So I'm going to let x be the base, and the height is 4 more than twice that. So the height would be 2x plus 4 or 4 plus 2x. What is the area of a triangle when the base is 16? Well, here's our formula. Our formula for a triangle is this, 1/2 base times height. What does it say? We have to write a function. So we have a equals 1/2. The base we have is x. The height we have is 4 plus 2x. So that would give me a equals 1/2 x times 4 plus 2x, which means I have to distribute a 1/2 x. A half times 4 would be 2, and a half x times 4 would be 2x. A half of 2 is 1. X times x is x squared. So that would be my formula. My formula would be 2x plus x squared, or you could also have x squared plus 2x. You could have also used b instead of x as well. You could have a equals b squared plus 2b or 2b plus x squared. So now it asks, what is the area of the triangle when the length of its base is 16? So we want to find the area, and the base would be 16, so we just plug in 16. And if you simplify that, 16 squared plus 16 times 2, that is going to give you an area of 288 squared inches. So that would be your answer, 288 squared inches. Part B says, let's graph it. So if you graph this, I'm just going to make a very rough graph, and we're doing the positive quadrant, so quadrant 1. If you plug in 0, now once again, I'm going back to this. This is the equation I'm looking at. If you plug in, I'm just going to make a really quick t-table. I'm going to plug in 0, 1, and 2. So if I plug in 0 here, 2 times 0 is 0, plus 0 squared, I'm going to get 0, 0. I'm going to plug in 1 and 2. If I plug in 1, 2 times 1 is 2, plus 1 squared, that's 1, so 2 plus 1, that's going to give me 3. If I plug in 2, 2 times 2 is 4, plus 2 squared, which is also 4, that's going to give me 8. So I'm going to graph by 2's here. 2, 4, 6, 8. So if we graph this, 0, 0, 1, 3, 2, 8. So if you graph this, the question asks, how do you know the rule is nonlinear? Because your graph doesn't make a line. You may now stop the video if you would like, but I am going to do practice A number 5 if you would like one more extra problem. 5. Write a function rule for the area of a triangle with a base 3 centimeters greater than 5 times its height. What is the area of the triangle when its height is 6 centimeters? So pause the video, do that yourself if you want some more practice. So if I'm looking at my formula, A equals 1/2 base times height. We know our height's going to be x because it doesn't tell us anything about it. Our base is 3 greater than 5 times that. So 5x plus 3 or 3 plus 5x. So this is my base, and my height is x. So I just plug them in. 1/2 times the base times the height, which is x. So I'm going to first distribute the x. 3 times x is 3x, and 5x times x is 5x squared. I'm just going to times everything by a half. So that would give me 3x plus 5x squared, all divided by 2. And now plug in the value of x, which is our height. Remember, x is our height. So x is 6. So all I'm going to do is plug in 6. So if you solve this, 6 to the second power, that gives you 36 times 5, plus 6 times 3, which is 18, divided by 2. That is going to give you an answer of 99. And the label is talking about centimeters, so squared centimeters. So my answer is 99 squared centimeters. So remember, in this chapter we went over how to write a function rule, an equation, how to write a rule and then plug something in by evaluating it, and then writing and evaluating a nonlinear function rule.